Hello, this lesson is about simplifying expressions with integer exponents. But in order to do that, there's some rules we have to learn. The first three may look familiar. We've used these before. So that says that an expression raised to the zero power, doesn't matter what the base is, but as long as it's to the zero power, the answer is 1. The second one says that when you're multiplying two exponential expressions with the same base, you actually add the exponents to get the result. And when you have an exponential expression raised to another power, like we do in Rule 3, you just multiply the exponents to get your result. Now, the next three rules, Rules 4, 5, and 6, may be new to you or not. You may have seen it in a previous class. So the first one, or Rule 4, says that if you have x to the m over x to the n, you can simplify that by subtracting the exponents. So you subtract the exponent on top minus the exponent on the bottom, and your expression is no longer in the denominator once you make that subtraction. But along with that rule, oftentimes you have to use rule number 5, because if you have a negative exponent in your expression, you always have to express these expressions as a positive exponent. And the way you do that is by taking the reciprocal of the expression and changing the exponent sign to its positive counterpart. So in other words, x to the negative 2 is the same as 1 over x squared. So just keep that in mind. You should never have negative exponents in your final answer. And then also number 6 is associated with number 5. If you have a negative exponent in the denominator, again, the way you correct for that is you take the reciprocal. So the reciprocal of 1 over x is just x, and the exponent changes from negative to positive. All right, so let's practice. Oftentimes when you're simplifying expressions with exponents, you are using one or more of these rules. So let's start with number 1. In number 1, this one's very straightforward. Your base is y and you are dividing. So you are only using rule number 4, where you subtract your exponents. So we get y equals 3 minus 5. But that result is y to the negative 2. So just like I mentioned, you can't have a negative exponent in your final answer. So then we have to apply rule number 5 here. And so y to the negative 2 is rewritten as 1 over y to the second power. So the exponent of y changes to positive, and now you're done. All right, so let's move on to number 2. This one doesn't have a whole lot to do. We just have to correct for this negative exponent. Well, 2xy squared raised to the negative 1, that's the same as 1 over 2xy squared. Now, it would be redundant for you to write to the first power. It's not necessary. So you really just express it as 2xy, 1 over 2xy to the second power. And that's it. We just erase this and we can move on. Okay, so let's go on to number 3. Here I have 4a to the negative 1, b to the second, times 2a to the negative 3, b to the negative 5. All right, so we are multiplying two monomial expressions. So I'm going to be using the second rule, which is the one that says that you add your exponents when you are multiplying monomials with the same base. So let's see what we do here. So you want to multiply your coefficients 4 and 2. So that's what you see on this line, 4 times 2. And then you want to add the exponents for the expressions with a base of a, as well as the expression with the base of b. So that's what you see here. I have negative 1 plus negative 3 associated with a, and 2 plus negative 5 associated with b. So you get 8a to the negative 4, b to the negative 3. So now I have to correct for those negative exponents. So I'm going to use rule number 5, that's above. So the a and the b will go below 8. 8 can stay in the numerator, but a goes to the denominator and becomes a to the 4th. B also goes to the denominator and becomes b to the 3rd. So the only reason a and b changed positions is because they both had negative exponents, and we had to change them to positive exponents by taking the reciprocal of a and b. All right, so here's the one, number 4. I have 2a cubed b to the negative 3, and that whole expression is to the negative 2 power, times ab squared. All right, so the first thing I did was correct for this negative exponent here by taking the reciprocal of what's inside of the parentheses. So it becomes 1 over 2a cubed b to the negative 3. Notice that inside the parentheses, nothing changed here. It just changed positions, but my exponent changed to a positive. And then the second expression stays the same. It's being multiplied by ab squared. All right, so now I did two things in this third line. I put ab squared in the numerator because 1 times ab squared is just ab squared. And in the denominator, I squared the expression. So 2 squared is 4. A to the 3rd raised to the 2nd power, that's rule number 3. Multiply your exponents, that's a to the 6th. And negative 3 and 2, that gives me b to the negative 6, again, using rule number 3. All right, so now I'm going to use rule number 4 in order to combine the a's. I have a's in the numerator and the denominator, and also to combine the b's because I have b's in the numerator and the denominator. So here, this a is a to the 1st power, even though it's not typical to write it. That's why here you see a to the 1 minus 6. Always take the numerator exponent minus the denominator exponent. And for b, it's 2 minus negative 6. So a to the 1 minus 6, it becomes a to the negative 5. 2 minus negative 6 is the same as 2 plus 6, so that becomes b to the 8th. This time, the only expression that has to move to the denominator is the a. The b already has a positive exponent, so the a to the negative 5 comes down and becomes a to the 5th, so you end up with b to the 8th over 4a to the 5th. All right, so there's 2 more examples here on the right. Let's start with number 5. So here I have 4 to the negative 1, x to the negative 2, y, over 4 to the negative 5, x, y to the 3rd. All right, so this is another technique that I haven't used so far, which is to not subtract your exponents the way rule number 4 does, but instead use rule number 5 and 6, which is this one where you're flipping the base and changing the exponent to its positive. And what that does for you is that you eliminate all of the negative exponents. So 4 to the negative 1 goes to the denominator as just 4. 4 to the negative 5 goes to the numerator as 4 to the positive 5. I did the same thing with x to the negative 2. That went below as x squared. And all the other expressions stayed in the same position because they did not have negative exponents. So in other words, this y here is still here in the numerator. This xy cubed in the denominator is still here. Xy cubed still in the denominator. So only move the expressions to either the numerator or the denominator, the opposite position, if they have a negative exponent and then the exponents change to positive. All right, so now that I have only only positive exponents, I can go ahead and combine whatever I can. So let's deal with the 4's first. So I'm going to do this in-between work right here on the right. I'm going to do 4 to the 5 minus 1. The y's also have to get combined. This is y to the 1 minus 3. And in the denominator, well, they're both in the same position, your x's, so all you have to do is add your exponents. not subtract them because there's not one in the numerator and the denominator. And you get the result that you see right here. You get 4 to the fourth, y to the negative 2 over x to the third. Okay, so 4 to the fourth power, that's 4 times 4 times 4 times 4. That works out to be 256, which stays in the numerator. But y to the negative 2, well, we know we have to move that to the denominator, and it becomes y to the second. So your final answer is the expression that's here in the box, 256 over x cubed y squared. All right, number 6. This one has a little bit more to it. I have monomials in 4 positions. I have a fraction with a monomial in the numerator and the denominator, and another fraction with a monomial in the numerator and the denominator, but the second fraction is raised to the third power. Okay, so what happens from the first line to the second line? So first let's talk about the first fraction. The only thing I did here is that I canceled the t's. Notice that I have a t and a t. I can just go ahead and get rid of that. So I just wrote 8s squared over 9s to the fifth, which we'll have to simplify more in the next line. But for the second expression, I cubed it. And cubing means that you have to do 3 to the third. That's where 27 comes from. And then you have to multiply your exponents. That's the third rule. So I get s to the negative 3 and t to the sixth. You have to do the same thing in the denominator. So 2 to the third power becomes 8. So that's the 8 in the denominator. The exponents here, the 3 and the 4 becomes s to the 12th, and the 3 times the negative 3, that becomes t to the negative 9, which is what you see here. So, so now we have these two monomials to multiply. All right, so there's more than one thing you can do, and it's not necessarily true that one is more correct than another. You just have to practice these until you get more comfortable with the rules and recognize what to do. So from the second line to the third line, I combined the s's and the t's within each parenthesis. So here I subtracted s to the second over s to the fifth. I did 2 minus 5. That's where the s cubed comes from. The 8 and the 9 stay exactly where they are. And then here I combined the negative 3 and the 12, subtracting them. Negative 3 minus 12 gives me s to the 15th, which is what you see here. And then I did the same thing with the t's. 6 minus negative 9 becomes 6 plus 9. So that's where the t to the 15th comes from. All right, so there's a little bit more to do because I still have s's in more than one position here. And I also have an 8 in the numerator and the denominator that cancel. And 9 goes into itself once and goes into 27 3 times. So my coefficient is just 3, and that's in the numerator. When I combine my s's, notice that here now we are multiplying. So when you multiply, you add your exponents. So I get s to the negative 18. T doesn't change, so that's still t to the 15th. So again, you can't leave negative exponents in your answer. So the 3 and the t to the 15th stay in the numerator, but the s goes below into the denominator, and the exponent changes to s to the 18th. Okay, so that's your lesson. Give the homework a try. Good luck.